Welcome back. We're about to start this panel of language ambition. So I'm very happy to have the opportunity to moderate this because we have 4 amazing speakers. So we are going to start with Pastor. So I'm going to introduce him. And each speaker has 15 minutes, more or less 17. And after this, we will have a brief discussion here. So Pastor Lopez Monroy, he is a researcher that focuses on the intersection of the fields of natural language processing, NLP, and computer vision by exploiting deep learning techniques. His PhD thesis received the Best Thesis Award by SMIA. This is the Mexican Society of Artificial Intelligence. And he has been a visiting researcher in several universities like University of Houston, Universidad Politécnica de Valencia, Universidad Nacional de Colombia. And currently, Dr. Lopez Monroy, he works at the Mathematics Research Center, CIMAT, at Guanajuato, Mexico. And he is part of the Computer Science Department. So welcome, Pastor.
Thank you for the introduction. I'm going to talk about this topic, vision and language. And this talk is going to be organized as follows. First of all, I want to give, what is this? Oh, we cannot see this, okay. I'm going to give a very general introduction about language and vision from my perspective. And also, I would like to talk about our work in this field. In particular, I want to briefly mention our work in multimodal adult profiling, and also about movie success prediction. And in the third part of this talk, I want to talk about on adapted strategies from computer vision and NLP that we have been used. So these strategies have to do with detection of depression and anorexia in social media domain, and also with early text classification. We will see what is that. So this is a multimodal space, a concept that is very popular in multimodal machine learning. And the idea is that we want to build a vectorial space that is very convenient to manipulate the information inside the machines. So the idea is to have different objects in different modalities represented in the same vectorial space. For example, you have text, you have images, you have voice. And the idea is to have this object near from each other in this vectorial space. You have to learn this space. In particular, language and vision has to do with this intersection, the intersection of NLP, computer vision, machine learning, and we are interested also in the intersection with deep learning. So, language and vision is a hot topic at the intersection of computer vision and NLP, and it is very common to see specific tracks in premier conferences of natural language processing and computer vision that has to do with this topic. And also, the goal of this language and vision area is to exploit or integrate techniques from both fields to boost the performance of the algorithms. So we will see some methods inspired in NLP or computer vision to approach NLP or computer vision. We will see multimodal representations, semantic visual search, text illustration. Some specific tasks using language and vision are, for example, maybe the most popular one, image captioning. In this particular model of this, the model is of Karpati. I fed the model with this image, and the model can automatically generate this sentence that says, a bus is parked on the side of the street. Another example is for this image. For example, we have the sentence that says a group of people standing in front of a building. It is not bad for a computer, but it can be improved, especially if you see the labels in the figure. We see that it says that it's a school of probability and statistics at CIMAT, Guanajuato, but that information is not exploited by this model. And after this example, we have a CIMAT, for example. We have a large building with a clock on the top. So that is an error. We have also a bias in the data, and we have to take care of this in these models. Yeah, and it's obvious if the model see many images with a clock in the top, for example, the Big Ben or church in Europe with these clocks in the top, you will have a model that will think that everything that is noisy in the top of a building, it could be a clock. This is other example from Kiros. In this work, we would like to have a vectorial space where you can perform specific operations between those objects in order to retrieve relevant information into a database. For example, in the first example, you have a blue car, and you want to use that vector that represent that blue card and subtract the blue word vector, then add a red word vector, and then you will end with a vector that is artificially created in order to retrieve these kind of images. That is the red car, for example. Or also you could have the image of the plane, where you want to subtract the flying word and add the sailing word, and then retrieve images of boats. This is other specific task, visual question answering. You give an image to the computer and you ask things about that image. For example, how many slices of pizza are there? Or is that person alone? Do you think that it's going to rain in that image? So you want that the computer answer that kind of questions. Okay, that is maybe the most popular task in this language and vision field or area. And I will talk about these two approaches, these two points. The first one is to combine visual information to textual information in order to predict specific things in some tasks. And the second one has to do with adapting computer vision techniques to NLP in order to perform prediction. So what is this, for example, multimodal auto profiling? In this example, we use the user history of Twitter of some users, and we represent that information using word embeddings or the back of words. And we use also the information that the user posts. For example, images from the history of the users. And the idea is to combine that information in order to improve the prediction. So we have some results like that one. We have for the class, for the users that has an age above 35 years, we will see patterns that says that kind of users post about parties, for example, post about food, books, and also some of the words that are used by those users. For example, for people with age above 50 years, we will have images about dogs, sports, conferences, and work, and also some of these topics. So that's the idea in this work, to combine textual and visual information to improve the prediction of a classifier. We also have this other work in collaboration with the University of Houston about movie success prediction, where the idea is to exploit textual, visual, and product features for predicting the likability of movies. So the idea is to avoid these cases where you have movies that had more budget than the income gross that they produced. In this work, what we do is to build a new data set. We have a data set of about 15,000 objects. Each object has 3 modalities of data. You have for each object metadata, subtitles, and also posters. In metadata, you have information like very successful directors and very successful actors. In subtitles, you have the information that we preprocess using lexical features, part of speech, tagging. We also extract word embeddings. We use syntactic features for these subtitles. And we have the visual part of the movies that are the posters. And we did a very simple thing here. We only use convolutional neural networks to extract features. In particular, we use BGG. And, well, you cannot see some results here, but maybe I will move this. These are some classification results using textual information. And almost in the last row, you will see the image information, the visual information. And the takeaway here is that combining this information, textual and visual information, you can improve the models. Instead of only using traditional textual features like embeddings, engrams, fast text, syntactic features, you can also exploit the visual information in the poster of the movies to predict this. And the first column corresponds to a binary classification. That means the movie is going to be success or not. And you have the F-score metric to evaluate this experiment. And we had some conclusions like the higher the rating, the higher the average gross revenue is. There are some genres that cannot sell at movie theaters, even though they are liked by people and have high rating, for example, drama or documentary. And we have product companies that can use this information in order to decide how to improve the process of the marketing. We have also some work on how to adapt some strategies to approach natural language processing problems. In particular, we are interested in early risk prediction on the internet. This is anorexia and depression. And we take in this work a very well-known strategy in computer vision that is known as the back of visual words. And in computer vision, in back of visual words, you have image patches that you describe using some specific descriptor. You use a clustering algorithm to produce features on those images. And the idea in text now, it's similar. You have words, and you have word embeddings, and you apply a clustering algorithm over that word embeddings in order to discover new topics, for example. And the idea is to represent each document by using an histogram of these topics. And this slide about cowboys and aliens is just a reflection that at least in our work, when we don't have enough data, we have to use traditional machine learning like SVM or clustering algorithms, and also word embeddings and neural networks, combine it in one model in order to improve the prediction. So this is very important now. Not only use maybe deep learning, especially if you don't have enough data, you can combine this and get good results. And the last work is about early text classification. In early text classification, you want to build a model, but you want to classify parts of the document, chunks of the document. You want to use the model and predict each sentence or each paragraph, for example, in order to get an estimating or a prediction in that point. And the idea is to detect as soon as possible a risk, for example. This strategy, we have used this strategy in sexual predator identification. The x-axis is the percentage of the information that you have in a conversation, for example. And you can see here that with 40% of the texts, you can identify sexual predator in those conversations in this data set. We also have this experiment for early detection of depression. You want to detect the depression as soon as possible with few information of the text. And we use the same strategy. Yeah, we had other words about NLP, but now bringing NLP to computer vision. For example, in the past, we proposed some visual engrams or some embeddings for descriptors in computer vision. This is other topic, but just to mention about this. Yeah, in conclusion, so real data is naturally multimodal, and machine learning methods should take advantage of that multimodality. And also the fusion of the textual and visual information could improve the prediction results. Yeah, we saw some methods from one area can be applied to the other, in specific from NLP to computer vision or computer vision to NLP. And this is useful in several tasks. And yeah, in this work we use the back of words as the pivot to build these strategies. This is my collaborators. And thank you very much.